inspection records keep pointing to the same hydraulic assembly. Every measurement passes, yet something refuses to feel right. They tell me the differences are too small to matter. I cannot convince myself to stop looking. A wartime factory rarely appeared in official battle reports, yet thousands of military decisions depended upon what happened inside its walls. Behind guarded gates, where machine tools ran day and night beneath dimmed lights, a single overlooked mistake could travel hundreds of miles before revealing itself over a battlefield or an ocean convoy. In one British aircraft factory during the final years of the Second World War, an ordinary production worker noticed a pattern that others dismissed as routine variation. Without rank, authority, or public recognition, that worker insisted something was wrong. The concern delayed deliveries, irritated supervisors, and challenged wartime urgency, but the quiet decision prevented a chain of failures that might otherwise have unfolded far from the factory floor. By the spring of 1944, Britain's aircraft industry had reached an extraordinary pace of production. Years of bombing, shortages, and constant adaptation had transformed civilian manufacturing into an immense wartime system. Factories operated around the clock under blackout regulations, employing experienced engineers alongside thousands of men and women who had entered industrial work only after the outbreak of war. Every completed aircraft represented the combined effort of hundreds of separate workshops producing engines, instruments, hydraulics, electrical systems, and structural components. The pressure to maintain output was relentless. Allied air forces were expanding operations over occupied Europe while preparations continued for the invasion of Normandy. Delays in production carried consequences extending well beyond factory schedules. Every interruption required explanation. Every rejected component represented time, materials, and transport already invested. In one aircraft assembly facility in the English Midlands, Margaret Ellis worked as an inspection assistant assigned to the final fitting of hydraulic control assemblies. Before the war, she had been employed in a textile warehouse, where careful record-keeping and attention to detail mattered more than mechanical knowledge. Like many wartime recruits, she received months of technical instruction before joining aircraft production. Her responsibilities appeared modest. She checked measurements, verified assembly records, confirmed serial numbers, and inspected hydraulic fittings before completed systems moved onward to final aircraft assembly. Inspectors higher in the organization performed formal acceptance testing, but workers like Margaret formed an essential part of the process. They noticed irregularities before expensive failures developed further down the production line. Most days followed a familiar rhythm. Components arrived from subcontractors. Assemblies passed through machining, cleaning, fitting, inspection, pressure testing, and installation. Shift whistles marked brief meal breaks before machinery resumed its constant noise. The factory itself reflected wartime necessity rather than comfort. Windows remained partially obscured against possible air attack. Heavy presses vibrated through concrete floors. Oil mixed with metal filings beneath workbenches. Every department displayed production targets alongside reminders that careless work endangered aircrew serving overseas. Mistakes occurred despite every precaution. A misaligned bracket could require hours of correction. Incorrect documentation occasionally delayed entire batches while records were reviewed. Such incidents frustrated management but remained accepted realities within large-scale manufacturing. Late in April, Margaret began noticing an unusual pattern involving hydraulic valve housings supplied from an outside machining contractor. Individual components consistently passed dimensional inspection. Pressure tests likewise showed acceptable results. Yet several assemblies required minor adjustment during installation because threaded fittings seemed slightly tighter than expected. The difference measured only fractions of a millimeter. Experienced fitters dismissed the issue. Metal expanded and contracted. Different machining batches always possessed small variations. Assembly tolerances allowed sufficient adjustment. Production continued. Margaret accepted those explanations initially. She recorded observations in inspection notes because procedure required documentation whenever repeated adjustments became necessary. Her reports disappeared into ordinary paperwork among hundreds of similar entries generated each week. Several days later, another shipment arrived from the same contractor. Again, pressure tests passed. Again, installation teams mentioned unusually resistant fittings. One fitter joked that the supplier must have sharpened its cutting tools differently. Nobody considered the matter urgent. Margaret did something uncommon. Instead of reviewing only completed inspection sheets, she compared records covering nearly 3 weeks. She borrowed previous batch logs from filing cabinets and arranged them beside recent documentation. Looking beyond individual assemblies, she observed that nearly every hydraulic unit requiring extra effort came from the same subcontractor during a particular production period. Nothing officially failed inspection. Nothing violated written specifications. Yet something appeared to be changing. Her immediate supervisor listened politely before pointing toward the pressure test results. "If the assemblies pass," he reportedly remarked, "the aircraft inspectors will pass them too." It was a practical response. The factory had delivery quotas. Thousands of acceptable components moved successfully through production every month. Delaying shipments over minor observations carried significant consequences. Margaret returned to work but continued recording every occurrence. She began noting serial numbers, machining dates, and installation comments independently from official paperwork. During meal breaks, she reviewed production logs, searching for additional connections. Within another week, a clearer pattern emerged. Assemblies manufactured before a particular date rarely required adjustment. Assemblies afterward frequently did. She approached a senior quality inspector responsible for hydraulic systems. Unlike production supervisors measured primarily by output, experienced inspectors often appreciated detailed evidence. He examined her notes without immediate judgment. Instead of relying upon paperwork alone, he selected several completed valve housings from storage and measured thread profiles using precision gauges unavailable at ordinary inspection stations. Measurements again remained technically acceptable. However, microscopic examination revealed something unexpected. The cutting finish inside certain threaded sections appeared rougher than earlier batches despite remaining within dimensional limits. The difference seemed insignificant until hydraulic sealing rings were installed under operational pressure. Rough machining increased friction during assembly. Greater friction occasionally twisted sealing rings slightly without producing immediate leakage. Ground pressure testing lasted only a limited period. Extended operational cycling inside aircraft during repeated missions might gradually damage those seals. It was only a hypothesis. No confirmed failures existed. Proving the concern required evidence management might accept. The senior inspector requested additional endurance testing beyond standard procedure. Production managers objected almost immediately. Extended testing consumed valuable equipment already operating continuously. Aircraft awaiting completion occupied factory space. Transport schedules depended upon planned deliveries. Nevertheless, permission was granted for a limited examination involving selected assemblies. Hydraulic systems underwent repeated pressure cycles far exceeding ordinary acceptance tests. Hours passed. Initially, every assembly performed normally. Some supervisors quietly suggested ending the experiment before more production time disappeared. Then, after prolonged cycling, one assembly developed a slow pressure loss. Inspection revealed a damaged sealing ring. Another unit exhibited similar wear. The damage did not create immediate catastrophic failure. Instead, repeated movement combined with rough thread surfaces gradually distorted the seals during installation. Aircraft entering operational service might complete several missions before symptoms appeared. By then, maintenance crews overseas would likely attribute leaks to ordinary wartime wear rather than manufacturing. The discovery transformed Margaret's earlier observations from routine paperwork into a serious production concern. Engineers immediately expanded the investigation. Attention shifted toward the subcontractor responsible for machining the valve housings. Representatives visited the facility carrying inspection samples and production records. They found no deliberate negligence. Instead, wartime shortages had forced replacement of several specialized cutting tools weeks earlier. Alternative tooling remained officially approved but produced slightly different surface finishes under heavy production conditions. Ordinary dimensional inspections failed to identify the subtle difference because measurements stayed within specification. The problem emerged only after prolonged operational stress. Further investigation uncovered another contributing factor. Inspection standards emphasized dimensions and pressure retention, but devoted less attention to microscopic machining quality inside threaded hydraulic passages. Earlier manufacturing methods had rarely required such scrutiny because original tooling produced consistently smoother finishes. As equipment changed during wartime shortages, inspection procedures had not evolved accordingly. The weakness belonged to the system rather than any individual worker. Production managers now faced a difficult decision. Hundreds of completed hydraulic assemblies already awaited installation or shipment. Rejecting them meant significant delays. Accepting them risked future reliability problems during active military operations. After consultation among engineering staff, inspectors, and government production authorities, affected batches underwent additional examination. Many assemblies required reworking. Others received replacement components. New inspection procedures introduced surface finish verification alongside existing dimensional checks. The subcontractor modified machining practices and received revised technical guidance. None of these changes attracted public attention. Factories routinely adjusted production methods throughout the war. Most improvements remained internal administrative matters. Yet inside the plant, workers understood the importance of what had occurred. Several fitters later admitted they had assumed the tighter fittings represented ordinary variation. Others acknowledged they had noticed the extra effort required but regarded it as unavoidable under wartime conditions. Margaret herself never described the discovery dramatically. Colleagues remembered her simply saying that the pattern continued appearing in the paperwork. She believed records deserved careful attention because they sometimes revealed problems invisible during individual inspections. The revised procedures soon demonstrated wider value. Additional component suppliers underwent similar surface finish evaluations. Several unrelated machining issues surfaced before causing operational failures. Engineers increasingly appreciated that acceptable measurements alone did not always guarantee long-term reliability under combat conditions. As Allied operations intensified across Western Europe after June 1944, aircraft demanded constant maintenance even under ideal manufacturing conditions. Combat damage, weather exposure, improvised airfields, and intensive flying schedules placed enormous strain upon hydraulic systems controlling landing gear, flaps, brakes, and other essential mechanisms. Maintenance crews overseas frequently praised equipment arriving from Britain in dependable condition without ever knowing how many manufacturing decisions influenced that reliability. No official record connected specific aircraft to Margaret's observations. No report concluded that particular crews survived because revised hydraulic inspections prevented future failures. Industrial history seldom permits such direct conclusions. What can be established is simpler and equally important. A documented manufacturing weakness was identified before widespread service use. Inspection standards improved. Potentially unreliable components underwent correction rather than routine acceptance. Those actions reduced unnecessary mechanical risk for aircraft entering operational service. Within the factory, production soon returned to its demanding pace. New workers replaced experienced staff leaving for military service. Supplies fluctuated. Air raid precautions gradually eased as the strategic situation changed. Margaret resumed ordinary inspection duties with little alteration to her daily responsibilities. She received no public ceremony. The factory manager issued a written commendation acknowledging her careful reporting and persistence in documenting recurring irregularities. The note emphasized that production quality depended upon workers willing to question routine assumptions when evidence justified concern. The commendation entered her employment record. Outside the factory, almost nobody knew it existed. When victory in Europe arrived in May 1945, industrial workers celebrated alongside military personnel throughout Britain. Factories that had operated continuously for years gradually shifted toward peacetime production. Temporary wartime employees returned to civilian occupations. Government ministries archived countless technical reports, production memoranda, and inspection revisions generated during the conflict. Margaret eventually left aircraft manufacturing and resumed civilian employment. Like many wartime workers, she rarely discussed the technical details of her factory experience. Family members later recalled stories about long shifts, ration books, bicycle journeys through blackout conditions, and endless paperwork, but she spoke little about recognition or achievement. Her role reflected an often overlooked reality of wartime industry. Victory depended not only upon remarkable inventions or famous engineering breakthroughs, but also upon countless individuals who recognized small inconsistencies before they became larger problems. Factories relied upon people willing to examine routine work with patience, even when urgency encouraged faster decisions. Military histories naturally emphasize campaigns, commanders, and battlefield operations. Industrial histories often celebrate aircraft designers, factory directors, and production statistics. Far less attention reaches inspection assistants, record clerks, machinists, gauge setters, and assembly workers whose observations quietly strengthened the reliability of equipment long before it reached operational units. The revised inspection methods introduced after Margaret's reports remained part of factory practice for the remainder of the war. Similar attention to surface quality gradually appeared within broader quality control guidance as manufacturers adapted to changing tools, substitute materials, and accelerated production methods demanded by wartime conditions. Such improvements rarely carried individual names. They entered procedure manuals, engineering revisions, and inspection checklists, becoming ordinary expectations for future workers who never learned why particular measurements or surface checks had been added. That quiet disappearance into routine practice may be the clearest measure of their success. The problem ceased being remarkable because it had been solved before becoming widespread. The worker who first recognized it returned to ordinary life without medals, newspaper headlines, or official histories devoted to her contribution. Yet every complex wartime system depended upon people prepared to notice what others accepted as normal, to preserve careful records when explanations seemed incomplete, and to persist respectfully until evidence received proper attention. Inside a noisy aircraft factory where speed often appeared more valuable than hesitation, Margaret Ellis demonstrated that careful observation could be as important as skilled machinery. Her name remained absent from famous accounts of the Second World War, but the quiet discipline she brought to an ordinary inspection desk reflected the unseen professionalism that supported countless operations beyond the factory walls, leaving a legacy measured not by public recognition but by failures that never had the opportunity to occur.